Hello, hello. Okay, so those of you guys who were not here today or are still a little bit confused about synthetic division, I'm going to go over these two examples that we did in class today. Okay. Um, so what we're trying to do is this here is not factorable by grouping, so we need to figure out how are we going to solve this degree 3 polynomial if it's not factorable by grouping. Okay, so what we're going to do is we're going to go ahead and divide this polynomial by x plus 1, and we're going to check to see if x plus 1 is a factor, because if it is, then we'll be able to factor this as x plus 1 times some degree 2, right? Maybe it's x squared plus 3x plus 5, whatever. This is not true, but if x plus 1 is a factor, then we can write it, the degree 3 polynomial, as x plus 1 times some degree 2. And then here we would get a solution, x equals -1. And then over here, this one is not factorable, but we know how to solve degree 2s that are not factorable. We can use the quadratic formula. And when we use the quadratic formula here on this degree 2, then we'll get our other two answers. So we'll get two answers here plus this one. That's 3 solutions for our degree 3. Okay, so what we're doing here is we're checking to see if x plus 1 is a factor so that we can write it like this. So the way we check to see if x plus 1 is a factor is by dividing. Just like if I want to know if 137, if 3 is a factor of 137, all I have to do is divide, right? I have to divide by 3. And if, and I get 1, 7, 5, 2. So I get a remainder, right? I get remainder 2. That's an R. Okay, so I get 45 remainder 2. So then I can say that, oh, well, 137 is, 3 is not a factor of 137, right? Because we got a remainder. If I have a number like 216, okay, and I want to know, okay, well, is 3 a factor of 216? Well, then I can try dividing. 3 times 7 is 21. 0, bring down the 6, and I get 0 remainder, right? So then that means that 3 is a factor of 216, right? And so I could write 216, I could factor it as 3 times 72, right? Okay, so we're going to be using this idea here where we do division to determine whether or not something is a factor. And we use this idea that, okay, if it has a remainder, like remainder 2, if there's a remainder, then it's not a factor. If we have a remainder 0, then it is a factor, okay? All right, so let's go ahead and take a look at how we divide polynomials. So we're going to be using the method called synthetic division. Okay, so here's the setup. Okay, so you're going to have this line. Okay, and on the left side over here is going to be the solution to this little binomial. Okay, so that's going to be x equals -1, right? I'm hoping you can do that in your head. The solution to this, if you take x plus 1 equals 0, subtract 1 on both sides, you get x equals -1, right? Okay, so that's how we get the x equals -1. But I'm hoping you can do this in your head. You don't have to do the work there. Okay. All right, so that's what goes here on the left side of this line. Okay, the solution to that binomial. So for here, it would be x equals 2, right? Okay, so and then over here, we are going to place just the coefficients of these terms, okay? So one thing that's important, I forgot, I skipped some parts. One thing that's important is that they have to be in descending order, Okay, so if they're all scrambled up, then you have to put it in order. So let me show you an example up here. Okay, so all the polynomials are in descending order. This is not in descending order. Okay, so it's all scrambled up. So you would have to rewrite this as start with the x cubed, and then the x squared, and then the x, and then the constant. Okay, that's how you rewrite it in descending order. Okay, highest exponent first, and then descend. Okay, and the other thing you need to watch out for is for missing terms, and you're going to use 0 for missing terms. Okay, so here, if you see, notice here, we have the x cubed, the x squared, but we're missing the x. Okay, so we need to use 0x minus 9. Okay, so these are two things you need to check before you start doing the synthetic division. Make sure it's in order, and make sure to use 0, like 0x, for any terms that are missing. If you're missing more than one term, make sure you put 0, whatever, 0x, 0x squared for the ones that are missing. Okay, all right, this one here, it's in order. We don't have any missing terms, so we're actually good to go. All right, so x equals -1, which is the solution to this. And now on this side of the line, I'm going to put the coefficients of this polynomial, just the coefficients, not the x's. Okay, so it's going to be 1, +9, +23, and 15. Okay, and then skip a line, because we're going to fill this in. This is an arrow. Okay, and we're going to be filling this space up with some other numbers. Okay, so the way you do synthetic division is we're going to go ahead and bring down this one. Okay, whatever number this is. If it's a 1, if it's a 2, a 5, a -3, whatever number this is. Okay, and remember, this is the coefficient up here. 1, 9, 23, 15. 1, 9, 23, 15. Okay, whatever this number is, bring that down. Okay, and then you take the number that's below this line, you take this number and you multiply it with this outside number. So 1 times -1, and I write the answer over here. 1 times -1 is -1. Okay, and then I combine these. 9 minus 1 is 8. Okay, and then I repeat the process. This number below the line gets multiplied by this. 8 times -1 is -8, and I put it here. Okay, 23 minus 8 is 15. Okay, and then 15 times -1 is -15, so I put -15 here. Add those. 15 minus 15 is 0. Okay, so that's how you do the synthetic division. Okay, so I want you to go ahead and see if you can try it with this one over here. Okay, so I'll help you set it up. Okay, and then I want to see if you guys can do it on your own. Okay, so to set it up, we want the solution to this binomial, so x equals +2. And then you put all the coefficients of this longer polynomial over here. Okay, so it's 1, 9, 23, 15. Okay, all right, go ahead and hit the pause button and see if you can figure this one out. And then we'll compare your answer to mine. Okay, so we're going to go ahead and bring this down, and then we're going to multiply. So always bring that down. Then you multiply 1 times this outside number. 1 times 2 is 2. Okay. Then we're going to go ahead and combine these. 9 plus 2 is 11. Okay. And then repeat. So 11 times the outside number is 22. And then add these. 23 plus 22 is 45. 45 times 2 is 90. And then here we get 105. Okay? All right, so that's how you do synthetic division, but now I'm going to talk about the remainders because we want to know if these guys are factors, right? We want to know, is x plus 1 a factor of this? Is x minus 2 a factor of this? And we said we're going to be looking, it's a factor if we have no remainder when we do the division. Well, we just did the division, and it turns out that this last number over here, 0 and 105, these here are the remainders, okay? So over here, where we have 0 remainder, then that means, yes, x plus 1 is a factor, okay? But down here, 105, we got a remainder of 105, so that's a big old no, okay? So no, x minus 2 is not a factor of this degree 3, okay? But here at least we found 1, and that's always good, okay? So that's all you have to do for the homework. You just have to check and determine if the binomial is a factor of the degree 3 polynomial. Okay, so you do your synthetic division. If you get 0 for the remainder, then yes, it's a factor. If you don't get 0, then it's no. Okay? All right, if you have questions, make sure you email me or ask me in class tomorrow.